Konnichiwa. Hello everyone from Tokyo, Japan. My name is Yoichiro Kasai and I work as a marketing for Olympus Japan. In this video, I want to show you how to analyze corrosion data by utilizing OmniPC 5 analysis software. OmniPC 5 is an analysis software for OmniScan X3 and is a free software you can download from our Olympus website. If you are an OmniScan X3 user, you may realize that the user interface is the same as OmniScan X3. It means that OmniScan X3 user can use the software with minimal or no additional trainings. Of course, you can do analysis on your OmniScan X3 flow detector, but you can do it more efficiently because of larger screen, mouse, and multiple shortcut keys, which I will explain later. The analysis starts from the optimization of C-scan, which consists of optimization of color palette and optimization of gate position. The color of the C-scan indicates the approximate range of the thickness readings. In this data, it contains color from red to blue, meaning the contrast of C-scan is optimum between the thinnest part and the thickest area. But you can edit the palette very easily if necessary by specifying the start and end point of the palette. For example, if you would like to stress the area thinner than 5 mm, you can realize it by left-clicking the red area of the palette, then specify 5 mm by mouse wheel. Then click blue area of the palette and specify the value as 5.1 mm. Like this. However, this is very extreme and eliminate very details of the data. So I will reset the value to the original ones. Like this. Very easy. You can achieve the optimization of gate position by checking the red area and white area. Position the data cursor on the red area by double-clicking to visualize the probe aperture in the S-scan and individual A-scans. You can simply check the A-scan by clicking the cursor, data cursor, and then using the mouse wheel like this. So you can check all individual scans very easily. Visualize the A-scan and ensure that the reading is valid and not the result of the interface at 0 mm, interfering with the gate or some other anomaly. Then, if necessary, you can edit the gate position like this. However, in this particular data, I think I don't need to change the start position of the gate. A data point where no indication is detected in the selected gate will result in a white pixel, like here, and will not corrupt the readings. It is normal to have some missed data point due to unfavorable beam orientation from the corrosion. If the pixel is white because the gate position is not appropriate, you can optimize the C-scan by repositioning the gate. Like this. Just lowering the gate while performing the analysis. This is very common and necessary to ensure the optimum C-scan for analysis and reporting. Fortunately, it seems that the gate position for white area in this data is good and not need to be edited. Now the optimization of the gate completed. The next step is actual analysis of the data. Corrosion is typically reported as the thinness data point and the general summary of the overall condition. To do so, I would like to use readings which represent characteristics of the data. Readings are available in pre-configured lists by application. You can display the readings for corrosion application by simply selecting corrosion here. Now, these are the readings for corrosion analysis. TA/ is the thickness at a specified position, and ML is the material loss at a specified position. For example, the thickness and material loss at this position is 2.62 mm and 78.2% respectively. S minus R is the distance between the red vertical cursor, called reference cursor, and the green vertical cursor, which is the measurement cursor. And IM minus R is the distance between the red horizontal cursor, reference cursor, and the green horizontal measurement cursor here. By using these four cursors, you can create a box or a zone. You can specify the position of red cursor by simply pressing Shift key plus left click, and you can also set the position of green cursor by pressing Shift key plus right click. Then, as you can imagine, T-min Z here displays the lowest reading within the rectangular zone on the C-scan. In this case, it is 2.62 mm. And S T-min Z reading is the position of the T-min Z on the scan axis within the C-scan. Scan axis. And the I T-min Z reading is the position of the T-min Z reading on the index axis within the C-scan. So in this particular case, S T-min Z is 13 mm and I T-min Z is 5 mm. Now I understand the thickness and the location of the thinnest part, and I also understand the overall distribution of the corrosion by the optimized color palette. So the next step is reporting. Reporting is very easy. Specify the indication and adjust both measurement and reference cursors. Like this. Then press the Add Indication button. So you can add indication to the indication table. Let me do the same thing for other indication, this area. And then just press the Add Indication. Once all indications are added, you can create a report by clicking the Report button. Like this. And you can actually save the PDF file by pressing this button, Generate PDF. Very easy and simple. And if you have your own original report format, or you would like to visualize the C-scan data by Excel, Microsoft Excel, you can export the C-scan data as a text file by simply right-click on the C-scan and select Export C-scan. You will find the exported text file in the Export folder and can create 3D representation like this very easy.